Hello everyone. So today let's look at Pythagoras' theorem in 3 dimensions. Now, because it isn't written on this page, I am going to remind you of Pythagoras' theorem, which is c squared is equal to a squared plus b squared. So that's a formula that we will be using for this chapter. Okay, so we have a bunch of 3D shapes that we could be working with. And we can use Pythagoras' theorem to help us find some side lengths of these 3D shapes. So coming down to example 1, we need to determine the length of AG, which is this diagonal across the cuboid. So, and we also need our example correct to 2 decimal places, so please keep that in mind. Okay, now obviously there is no straight way to find AG. We are going to need to find some other side lengths as well. So having a look at this cuboid, we are going to need the length of EG to help us out. So looking at this triangle here, I'm going to pull it out. This is the triangle EG and H. And we have the length 10 down here, and the 9 of the length GH corresponds with E to H. So I'm also going to pop that there as a 9. Okay, now the hypotenuse is our C side. That's what we're finding. That's the length EG. So putting that into our Pythagoras' theorem formula, we have C squared is equal to 9 squared plus 10 squared. So C squared is equal to 81 plus 100. So C squared is equal to 181. Now to find C by itself, we square root that 181. Now my recommendation to you is to keep it as an exact value, just because the more you cut off your decimals, if you do put in a decimal value, the less accurate your final answer will be. So try and keep exact values for as long as you can. Okay, now looking back at our A to G line, we can see this diagonal triangle. If you can visualize it, I'll draw it out as a 2D shape here. So we have A, G, and E. So we just found E to G, which is the square root of 181. A to E corresponds with the B to F length, which is 5 centimeters. And then A to G is going to be my hypotenuse again. So using Pythagoras' theorem, we have C squared is equal to 5 squared plus the square root of 181 squared. So C squared is going to equal 25 plus 181, because the square root and the squared are going to cancel out. So C squared is going to be equal to 206. So C is equal to the square root of 206, which as a decimal value equal to 2 decimal places, it equals approximately 14.35 centimeters. Please don't forget your units on the end of the answer. Okay, coming down to example 2, we have a worded question. So a piece of cheese in the shape of a right-angled wedge. So looking at a right-angled wedge, it is up the top, but I will redraw it down here. So we're looking at a piece of cheese that looks like this, sits on a table. It has a rectangular base measuring 14 centimeters by 8 centimeters. And the height is 4 centimeters at the thickest point. So an ant crawls diagonally across the sloping face. So the ant's path is from up here to down here. How far to the nearest millimeter does the ant walk? Okay, so I'm going to stick with my centimeter units and then convert my final answer to millimeters. So similar to the other question, what I'm going to need first is this. I'll change that to a blue line. The length of this blue line here. So I can see that I've got this triangle here. So with this triangle, this bottom corresponds with my 14 centimeters, and this is my 8 centimeter line. So using Pythagoras' theorem again, I have c squared is equal to 14 squared plus 8 squared. So c squared is going to be equal to, c squared is going to be equal to 260, which means that the square root, that c is equal to the square root of 260. Okay, so we've found now that diagonal at the bottom, which is going to help us with our ant pathway. So our ant is walking down the hypotenuse, and we just calculated this measurement here, which is 260. So this vertical line here is the height of our cheese, which is 4 centimeters. So calculating our hypotenuse again, we have c squared is equal to 4 squared plus the square root of 260 squared. So c squared is going to equal 16 plus 260. So again, c squared is equal to 276. So c is equal to the square root of 276, which is approximately 16.61 centimeters. So we do need to convert that to millimeters. So to convert centimeters to millimeters, we multiply by 10. So we have 166.1 millimeters.